We will be concluding the broad field of mechanics in Module 3. Up until now, most of the concentration has been on solid objects in motion or in equilibrium. Fluids are also subject to applications of conservation of energy and momentum, and forces can be applied to them, both in open and closed situations. Chapter 9 covers much of this, addressing the competency used Bernoulli's principle, Archimedes' principle, and Pascal's principle to solve basic fluid problems. The latter two have application in closed fluid situations, whether liquid or gases. In this case, the application of forces is explored. The former, along with what is known as the continuity equation, AV is equal to constant, where A is the cross-sectional area of, say, a pipe, and V is the velocity of the flowing fluid at a point where the cross-sectional area is measured, are effectively an application of the conservation of energy and momentum, sort of, for fluids. So once again, we have application of tools from previous chapters applied to new phenomenon. The remaining 3 chapters look at the application of Hooke's law, simple harmonic motion, and by extension wave phenomenon. This is first introduced in Chapter 10, with application of Hooke's law extended to solid bodies subjected to stresses and strains. Simple harmonic motion is then introduced and expanded on for objects like springs and pendulums, as well as objects undergoing repetitive circular motion. Wave equations describing the displacement, velocity, and acceleration of such objects are also introduced. Waves are further expanded on in Chapter 11. Different types of general waves are defined, along with characteristics that can be used to describe waves and wave interactions. Phenomena associated with waves such as reflection, refraction, superposition, interference, and diffraction are also introduced, tied to the wave equations first developed in Chapter 10. Chapter 12 looks specifically at the wave phenomenon known as sound. The formation of sound waves and how such waves are heard and detected is explored. The Doppler effect of waves produced by moving objects is discussed, with applications used in medical detection technology. We will find that the speed of sound in a medium is related to the temperature. This provides a nice segue into thermodynamics, the topics covered in the 4th and last module in this course.